whole number up. So you're being nice to yourself. Everybody should have gotten a class width of 3 at the end. No matter if you're looking at the mamas or the papas. Some of you guys got like 2.666, and some of you guys got 2.83 something when you're doing your class width, right? Give me some recognition, okay? And then so you round that up to 3. Even if you got 2.17, you would round up to 3. Because if you round down, your classes are not going to be as wide as they should be, so they're not going to cover all the data. You would need one more class, and that's kind of going against what you said you were going to do. So, for the mamas, ladies first, so we'll do the mamas. I think the shortest mama was 55, right? Mm-hmm. Yeah. Okay. I keep thinking about Johnny Bravo now. So it was high minus low divided by 6, in this case, 6 classes. Never divide by the number of data points. If you have 36 little rectangles, that won't be very useful. A few of them will exist, and most of them won't. So for mamas, it was, who was the tallest?
72.
72, yeah, 6 foot.
6 foot 2.
6 foot, and minus 55 divided by 6. And that came out to be, alright, 2.8, blah, blah, blah. And then so you round it up to 3. You can round that up to the whole number. So then you take the smallest. How you guys doing? Sorry, yeah, you got to catch up somehow. But for right now, you don't have to start at the smallest data point. That's a little point of flexibility. So you got flexibility in how many classes you choose. You don't have to, but normally it makes sense to start right at the lowest data point. Where you end up and what all the classes, they don't have to have any damn thing at all to do with the data points. There just has to be a class for every data point to go into. So you don't, if you say, oh, I didn't end at the last data point, you know, you're not supposed to. This is a width, who knows. So now I can do this like this. So now it's a width of 3, so this is easy. Now very quickly, let me just show you. The other way to do this would say 55, and the next class would start at 58, but then they would do this. And I personally just hate that. Now, one way that that's better is I won't make the mistake of including 58 in the first class. But a big way that's worse is you'd have to use 57.5 and 54.5 when you go to make the graph. Okay, let's not do that. Screw that. Let's not do that. Unless you know that and you like it, you can do that way if you want to, but let's not do that. So what would the next class look like for the mamas?
58. 61.
61, and so forth. Right? Are you guys with me? So you should end up with 6 classes. And everybody that did the mom's data should have ended up with, where's it at? 1, 7, 11.
962.
Beautiful. 962. And then the relative frequencies, 2.8%, 19, 31, 25, 17, 5.6. You could do some more decimals out there if you want to, but by hand, you know, at most 1 decimal place. I don't know. If you're able to do 2 decimal places by hand, oh, okay. Roughly, right? You guys might have had some decimals. Yes?
When you're adding up the relative frequency, isn't there there was like a buffer? Like it goes from like 99 to...
Oh, yeah, definitely.
It doesn't have to always...
Yeah, exactly. Because I've rounded in a few places here. So if I just happen to round down on every one of them except 1 or 2, it's probably going to be lower than 100%. Right? And if I happen to round up more often, it's going to be over 100%. But, I mean, if you get below 98 or above 102%, you're definitely, something's wrong. And I would say this is even should be closer. I'd say 99 to 101. But somewhere in there means that you're probably okay. All right, how are we doing so far? And there's another little issue. Don't, and I'm not picking on anybody, but don't do that. Right? Because it's decimal, and then you have to convert it to the percentage. So don't just slap a percentage symbol on there. Be careful. Oh, you got really, really, really tiny little rectangles. All right. How's that so far? Is that all right? That's the mamas. For the papas, the class width was the same. It was like 77 minus 61. And that was like 2.6. And so you rounded to 3, so you got the same class width. But the shortest one was 61. And then you go up to 64, and then 64, up to 67, so forth, right? All right, cool. And then the number should have been, these guys are a little less varied, 469971. That should have been the numbers for those. And then the percentages should have been 11, roughly, 17, 25, 25, 19, 2.8. So that's really rounding a lot, but that should be roughly what it was. Is that cool so far? You guys all right? Some of you guys are looking at the floor. I feel bad. I'm sorry. The floor is more interesting right now, Jeff. All right. I can't compete with the floor, but that's all right. So here's what they should look like. And then I want to show you something interesting from the survey you guys did. I just got to look angry at it. So there's that one question while this guy wakes up. There was that one question on the survey where I asked you to pick a random number. So just like on Mythbusters, did you ever see the episode where they determine which bathroom stall you should choose? So people skip the first one because they just assume everybody takes the first one. But everybody makes the same assumption, so nobody takes the first one. So that's the human condition. So the same kind of thing happens. Let me do this real quick before we do this, since I'm talking about it. So I asked you guys to pick a random number. And what happens is your brain says, let me pick one nobody else is going to pick. And this is not the prettiest way to present it, but StatCrunch does this very quickly for me, and this is a nice quick way to show you. Do you guys see what this means? How many 7s were chosen? 12, good. And the next highest number was 8. Always 7 is the most. Only one semester I had the 8s were one more than the 7s. For whatever reason, because 8 is lucky in a lot of cultures, so maybe that was why. I don't know. Or maybe, actually, a few people told me they already knew about this. Now, personally, I love this person. I don't know if that was, if you're saying I can't choose between 4 and 5, or I reject your question, Jeff, and I replace it with my own. I love it. In my other class, I had some people picking pi and stuff like that. And I thought about changing the question to be pick an integer or a whole number, and then I thought, no, I want to see what my smart asses are. So, or I'm not sure. 2 people picked 45. That is really, really weird. But it's interesting. The brain thinks 7 is really a weird number, so you think not an even number. Everybody's going to pick an even number. Of course, that's why not many people do. And then you think 7 is weird. 5 goes into things. Your brain picks 7 because 7 is a weird number. 7 doesn't go into things easily. It's just a weird. So your brain says that's the most random. So the brain obviously has trouble with randomness. We are bad places to go to pick random numbers. We are bad places to go for that because our brain is not hardwired for that. There's too much other psychological shit going on there. This is an interesting conjunction of science, of math and psychology. Right? Anyway, that's enough of that. All the other responses, I'm going to use them to create sets of data like this for you guys to analyze. So here's the mother's heights. Should have looked roughly like that. I made a relative frequency one. I don't know why. Let's take a point off for me. So I asked for a frequency distribution there, right? And then, so that's what that should look like. So the shape should be roughly that. Is that cool for the mamas out there? All right. And then the papas. Papas are a little less interesting.
Can you go back to the mother's yard?
Oh, I'm sorry, real quick. Another thing. It's easier in Excel. This is what's called the midpoint. And you could use midpoints to graph also. So, for example, 68. Where's the mamas? Oh, let's use an earlier one. 56 would be the midpoint sort of between, and to be honest, to do it really quickly in Excel, so it would be nice, I did it this way. And so 56 would be the midpoint, right? That was the quickest way for me to just make this, so I didn't have to go and define these and blah, blah, blah. It's crap.
Because I was wondering, because there's no 55 and there's no 72, but then both ends represent those numbers.
Oh, yeah, so that really does start at 55 at the end. Yeah. All right, how are we doing so far? So those are like midpoints. I wouldn't use midpoints for the inequality, because what would the midpoint be of these?
56.5.
Do it again, sorry.
56.5.
Yeah, how'd you get that? 3 divided by 2 is 1.5, and then you add it on, right? So you get 56.5. That would be the midpoint if I was doing it with the inequality way. Right? But it's just easier, just put 55, 58, you know, that's fine. How we doing? So for you guys, it should be 55, 58, 61, 64, blah, blah, blah. And then the papas, again, should look like this, roughly. That should be the shape of it. Cool, right? So how do we feel about that? Histograms should not be a huge deal. You just got to get a little used to the math behind them, and then bam, they're quick and easy. Should be. All right, cool. So any leftover questions over histograms, frequency distributions? So this here is a frequency distribution. This is a relative frequency distribution, and then you use that to create the appropriate histogram. That's the connection. All right. Cool. Some of you guys look like you're judging. Bad marks. Okay. Shit. So now I want to get into, if there's no other questions on that, I'm going to get right into section 2.3. I love person. So who amongst you has taken the SAT or the ACT, something like that? When you get your results back, do you remember how you got them back? What kind of numbers did they give you? Do you remember? Or is it too long ago?
Yeah.
True.
You gave like a total of the points you earned, and then they split it up into like what subjects.
True. Did they not give you any percentiles anymore? Like you're in the 84th percentile for this and so forth? Yes. They should. And we're going to talk today about why that is better than just giving you like a flat grade. The percentile is actually more important. So what are they, talking about the SAT, even if you haven't taken it, what do you think they do with the SAT every now and again, every few weeks? Yeah, they change it just in case somebody has a photographic memory and they just go in and remember all the questions. They got to change the questions, right? So if they change it every now and again, could they happen to randomly change it to be harder than it was last week? Yeah. Hell yeah. So if you compare, if you're one of the unfortunate people that happen to take it when it's harder, you shouldn't compare your score to somebody else's score that took the easier test, right? That doesn't seem fair. You guys with me? Yep. So what they do is they compare your score within the group of people that took your test. So if you got, all right, so let's figure out first what these percentiles mean, and then we'll talk about, let me see, do I need this? No. Go all the way back. There you go. Let's talk about what they mean first. So if I want the 80th percentile, if you're in the 80th percentile amongst a group of people for how far you can jump, I'm going back to my early PE days, right? We use this symbol for percentile P80. That means the 80th percentile. Are you in a good place compared to somebody who is in the 30th percentile? Yeah. So what truly does 80th percentile mean? Does that mean you made 80% on a test or something?
You're better than 80%.
Good. Your score was higher than 80% of the other people's scores that took that same test. So now, going back to what I said earlier, if you're in the 80th percentile when you took the harder test, you would probably be about the same percentile when you took the easier test, because everybody would probably do a little better. You're measured relative to the same people that took that same test. You guys understand? So it's not a flat score. It's much better to look at the percentile because then that tells you if the test gets harder, everybody's score probably goes down, but you're in the same position relative to everybody. So you would be at the same percentile. That makes it fair. All right? So otherwise it would suck. I just happened to take the really hard one. Shit. So thankfully they do this for us. So let's see what your intuition tells you. And it's going to tell you wrong. That's all right. We're going to correct it. So I'm going to make a very small set of data. Whenever you have a very small set of data, things don't work perfectly because it's a very small set of data. If I only have 10 data points, I'm going to make 10 data points here. I'm not even counting. Where am I at here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Hey, look at that. All right. So do you understand? It would make no sense if I talked about the 33rd percentile versus the 34th percentile. They're probably going to be the same damn number because there's so few numbers to pick from. Do you understand? So, but this at least is going to get us to understand how to find these percentiles. So what does your gut tell you the 80th percentile should be?
The 8th one.
All right, so the 8th one. 1, 2, 3, 4, 5, 6, 7, 8. One choice might be the 8th one. But now think back to what we just said. That makes sense in one sense because 80% of 10 is 8. That kind of makes some sense, right? But if I'm in the 80th percentile, how many people should be below me? 8. 80% of them. So then, if 8 people should be below me, then it should be this one. Let me let that sink in for a second. You guys with me so far?
Yeah.
But if I'm in the 80th percentile, what percentage should be above me? 20%, and that should be 2. Holy shit! So what I do is I average these two. I average those two. So here's a general way to find this. Now the book eventually tells you the way I'm going to show you. That works no matter how large your list is. One way to find quartiles or something is to like cut it in half and then cut it in half again, but that gets really weird when you have a really long set of data. I'd much rather just be able to calculate where to go to get the answer. Right? So here's the 2-step process. I normally talk really fast, so when I slow down, it's a very important point. So 2-step process to find percentiles. And you see how I put a little K there? That's a little variable in case you want the 60th percentile. It would be the Kth percentile. Don't freak out about that. Well, let's bring 80 back in for right now. The first step would be, it kind of makes sense like you said, you want to go 80% of the way into your data. So you would take 80% of the total data. So in this case, it's 10. So does that make sense? If I want the 80th percentile, I should go 80% of the way in. Now, what is it about the way I set this data up that makes all of this make any sense at all? The data is in order. If it's not in order, all the work you're doing is shit. It wouldn't make any sense. You can just go, no, I want this one to be the... No, you can't. It's got to be in order for this to make sense, right? You just put him way up there. I'm like, the 100th percent. No, screw you. You're done. So what is 80% of 10?
8.
8. That's crazy.
So you gave us 10 numbers for a reason.
Somewhat. I gave us 10 numbers just because it's easy to see them all and to talk about real quick.
Because I was thinking if you gave us an odd number.
I got you. We're getting there. If this number comes out to be a whole number, the answer is going to be this one and the next one averaged. Right? So it came out to be 8, not 8 point anything. If it comes out to be 8 point something, you round up. Then the answer would be the 9th one. Let me say that again. And we'll do another example where it does this. Whole number, you take that one and the next one and average them. And that matches with what we said should happen up there, right? And think about it. What's the only number up here that has 8 numbers below it and 2 numbers above it? The number that's in the middle of those two, isn't it? That's the only number that would have that happen. Does that make sense? And this is what the math looks like behind that. In case you have 212 things in your list, and it's not as easy just to look at as this. right? You just take 80% of 212. If it comes out to a whole number, you average it with the next one. So that's why it's a two-step process. Don't tell me the answer is 8. That doesn't make any damn sense. 8's there. That's not the 80th percentile. I did good on the test. No, you just failed twice. Shit. Evil. I'm a math teacher. And so the second step is go get the damn answer. First step, where's the answer? Second step, go get it. So if you average 27 and 29, what do I get? That's crazy. So then P80 in this case would be 28. So the person that scored a 28, maybe this is the ACT, I don't know, because they have the smaller scores, would be in the 80th percentile.
So you had 27 and 29, what'd you divide it by?
Oh, divided by 2, because it's just two numbers. Just take the average. Cool. Yes, ma'am.
You had said if 8 had come out to a decimal point.
So let's do another example. You ready? Okay. And this is where 10 numbers, again, they just don't make sense for certain values. But let's try this. Try to find P35.
Are we using the same scale?
Yes. So do the 2 steps. Alright, so let me catch up to you guys. So the first step, if I want the 35th percentile, I should go 35% of the way in. So it's always 35%, that percentage of how many data points I've got. And so what is that? Is that a whole number? No. So you round up. If that would have been 3.002, you round up to 4. So the answer is the 4th number. So go find the 4th number. So P35 is 16. Bam. So hopefully it makes sense to you. Since I have such a small set of data, the more precise percentiles don't really make as much immediate sense because there's only so many points to pick. So if I did P36, it's 16. If I did P31, it's 16. There's only 10 data points. Some of them got to be repeats. You can't be that precise. You with me? So if you told me you got 4 doors in your car and I say, be more precise, then, 4. 4.000, I can't, I got how precise? It's the same thing there. So the larger your list is, the more, then 31 and 32 and 33 percentiles could be different. Because there's more data points to pick from. Okay, maybe. But this, I just wanted to do this because it's easy to see it, and you can see the process doesn't change just because of the size of the list. Of course, this will change. If you have 212, you're going to put a 212 there. All right. How are we doing so far?
Yeah, give us another one.
Okay.
Yeah.
Using the same data?
Yeah.
All right. Let me give you this. I'll build into the next topic at the same time because that's just what I want to do.
I got a question. Why didn't you? So why for the first one you divide by 2?
If it comes out, if this step comes out to a whole number, you average that one with the next one. If it comes out to anything else, you round up to the next.
And that's it.
And that's the answer. That's the only 2 things that can happen.
Got it.
Yes.
But is that truly the 35th percentile if you're rounding up? Because it seems like the first one was more specific.
And again, there's only 10 data points here. If I had 100 data points, then it would take me a while to write them all down, but then it would make more sense. You could really see then there would be a P34, and there would be a different P35, and a different P36. Do you see what I'm saying? Here, the 16 is P34, P31, P32, they're all 16, because there's only so many numbers to pick from. Do you guys see what I'm saying? Yes?
If it happened to be like in between 27 and 27, so it's...
Oh, then it'd be 27. Yeah, you truly average them. So yeah, if I did the 70th percentile, you'd average these two, 27. I like it. Yes, sir.
Because we're not going to average the 16, correct?
Here?
Yeah.
Oh yeah, so it came out to not a whole number, so I round up and I take that number. That's the answer. I like it.
And since it's out of 10, you go to the fourth place?
Yes, so the fourth number, 1, 2, 3, 4. Yeah. So if this came out to be 3, I would average the third and fourth one. So if it comes out to be a whole number, you average those two. And let me ask you this. Let me ask you this. What about P50? What's special about P50? It's the one that's in the middle. So if I have 5 data points, which one's in the middle? Yeah, let me keep these up. The third one. Right? But what's half of 5? 50%. What's half of 5?
2.5.
And if I round it up like I just said we should, you go to 3. Holy shit, it makes sense. Just when you start getting into more and more precise percentiles, they might not make immediate sense depending on how big your sample is. But the work still gets you to a place that makes sense. I mean, 16 is going to have to be the answer for several of them because there's only so many that will work. This is roughly 40% of the way in. So anything around 40% is going to have to be that answer. Because that's the only number that's in that area, right? If I had 100 numbers, then there would be several numbers near 40. There's all these numbers to choose from. Then there could be different ones for different ones.
For the 80th percentile, 28 is not on the actual list of
Good.
numbers.
That's right. But 28 is still that percentile. The 80th percentile is 28. So the answer to a percentile or anything else related to percentiles don't have to actually be in the data set. Yeah. Because coming back, if I had 4 numbers, what would P50 be?
2.
Is that in the middle?
2.5.
So what's in the middle of 4 numbers? The number that's in the middle of these 2 would be in the middle, right? So half of 4 is, that's a whole number. So I average the second and third. Isn't that the thing that's in the middle? Yeah. The average of those 2? I like it. So if there's 2 numbers in the middle, the number that's most in the middle is the average of those 2. Sounds like a line from Dr. Simpson. What's that?
No, I got it.
You got it. Cool. I like it. So real quick, P50 is also known as what quartile? What do you think quarter? Like the quarters of a game. P50 would be halfway, so it's which quarter? Second quarter. So it's the second quartile. We like these aisles on this. We have deciles for like 10, 20, 30. Those are the deciles. Who cares? I don't break it down that far. But the steps don't really change. Right? Half of 10 is 5. That's a whole number, so how do I find it?
5 plus 6 divided
So the 2 steps, 50% of 10. It's 5. Say it again.
5 plus 6 divided by 2.
Good. The 5th and the 6th number divided by 2 will be the answer. And now watch. Let's count our way in. Let's go. Oh, shit. So it's got to be the ones in the middle of those 2, right? If you try to just physically go to the center, you're going to have the same thing that math is trying to tell you. Average the 5th and 6th ones. So when you have a small set of data, it's actually easier just to kind of count your way around. But the process I'm showing you works for no matter how big the set of data is. So the second step now, 5th and 6th average would be, let's say, 21.5. Cool. I like it. All right, so do this for me. For this data, find, so we got Q2. Let me put that here. Find Q1 and Q3. Am I in there? Yes. Okay. Shoop. I like to look at some of your faces. Just make sure everybody's on the right track. Q1 is also known as P25, the first quarter, right? So then you just got to take 25% of 10. Let's get me started. show you a shortcut for Q3. You guys got Q1 yet?
Yes.
So 25% of 10 is 2.5. So what do?
Round up.
Round up to the third one. So people tell me the answer is 3. Don't do that, because 3 is way the hell down there. He's in the freaking 0th percentile, right? So P25 is the third number in. 14. Now here's a beautiful thing about Q3. If Q1 is 3 in from that side, Q3 is 3 in from the other freaking side, right? So I don't do all this other work for Q3. Does that make sense? 25% of the way in from this side is Q1. 25% of the way in from this side is Q3. Because then how much would be down here? How much would be below it? If I go 25% of the way in, how much is below it? 75%. And Q3 is another name for P75, the third quarter, 75. Okay, man, you guys. Oh, some of you guys are like, let me put on a bold face. Sure, I'm with you. Freaking clue. So I'm hoping you do. If you don't like the shortcut I just did, you can just do the work. 75% of 10 is 7.5, rounded up to 8. The eighth number, 1, 2, 3, 4, 5, 6, 7, 8, is the third number, 1, 2, 3 in from the top. Same thing.
It's 27.
27. Kick ass. This man's like, just say the number, please. All right, how are we doing so far? This still isn't horrible stuff yet. I like it. It shouldn't be. It just takes a little getting used to. Now, let me tack on two kind of silly things. What's the lowest data point? 5. What's the highest?
31.
How many numbers are up here?
5.
So we call this the 5-number summary because we're creative math people. That really is the name. That's not me. That's 5-number summary is here. And let me go ahead and show you this, just to make things a little easier for you. I'm going to show you, the calculator costs enough money. I'm going to show you how the calculator does this for you. Of course, you should know me by now, maybe. You can use the calculator to check your work, not to do your work. Right? There will be a few things I'm going to let you use the calculator to do it, but I'm going to make very clear what those are. If you're not sure, you show me the work. Some of you had me before, you're like, yes, I know that all too well. Good. While this guy is... Oh, you're there. I'll stop talking bad about you.
Okay.
Okay. Take this away. Oh, crap. Wow. Sign out. Go away. Go away. All right. So if you take a second and put this into your list, the data points, 5, 11, and so forth. If you don't have a calculator, just watch along with me. Let's see. So you can clear list 1, go to list 1, and then hit clear, enter. So list 1 is clear. This list is clean. So let's see, 5, 11. This is the exciting part. Alright, it's all in there. Cool. Alright. So now watch this. This is kind of nifty. You ready? Hit stat. It seems like a very important one. Go to calc. We haven't gone over there yet. Go over to calc. So you hit the over arrow to go to calc. We're building a big screen. All right, so everybody here that's trying to play along. All right. How many how many variables did I just put in there? Be very careful. I didn't put 10. How many variables? 1 with 10 values, right? So I want to do 1 variable statistics. You see that very first thing? So if you just hit enter. Now this is nice. You normally have to tell it which list, but it defaults to list 1. So if your data is in list 1, you just hit enter. All right, let me stop here for a second. It's telling us way too much at the moment. You guys might not even know what the freaking hell. You've seen this before, maybe on sorority things or fraternity. Sigma, sigma, sigma. So that's the uppercase Greek letter sigma. Let's bypass all this shit. We're going to talk about every single one of these eventually. But look what it tells you at the very end. Low, Q1, Q2, Q3 max. Is it the same thing we got? Yay, thank God. So you can use your calculator to check your work, but you must show me the work. It's nice to be able to check your work at least, right? How are we doing so far? All right. Now, real quick, the other stuff, some of you guys have taken stats before, you know what some of the stuff is. But this very first one, whenever you see a bar over a letter, that means that's the mean or the average of that variable. So if you average those numbers together, you get 20.3. If you add them up, you get 203, which makes sense because there's 10 of them. And so forth. And so, well, we'll get into this. But that's E, that's sigma. It's the capital Greek letter S. That means sum. So when you say sigma x, it means sum up all the x values. So if you added all these up, you get 203. What do you think that third line means? What would you do first? No, you would square first, because that's the sum of x squared. All right, well, we'll get into that later. Just want to point that out now, because you'll see this, and I wanted you to know a little bit about what this is. Okay, enough of that.
Can I ask a dumb question right now?
All the time.
How did you get onto the variable stat thing?
Oh, sure.
Because I was doing all that like that.
Sorry, buddy. So you put the data in, and then you get stat, and go over to calc. Anytime I want to analyze my data, I'm going to go to calc for calculate something. And the very first one is one bar stats. Now, of course, the second one is going to be when we have like the number of beers you drank last night and the grade you made on the next test the next morning. That would be two variables, right? So then I could use two variable stats to find out some stuff between those. How's that sound? And that's actually I videotaped that lecture, and that's how I got the job here. Because I mentioned beer. I come to find out later, your teacher works here because he mentioned beer, and that excited the other math teachers. I don't mind professing that to be the truth. All right. What else I want to show you on there? Nothing on here yet. While we got this up here, and right now, just make sure you guys are with me. We're in section 2.3. I'm going to bleed over to 2.4 for a second, and then I'm going to come back to 2.3, because 2.4 is all about this. So I don't care what list of data I give you. You could calculate this no matter what. You with me, right? If I give you 80 data points, you just put them in order, and you just calculate these the way we did. You can always get this. Now watch. This is crazy. Have any of you ever looked at, you're thinking about where to transfer college-wise? Have you ever looked at like the Princeton Review of Colleges or some kind of college reviews or anything? No? Yes? Very often they'll say like the middle 50% SAT scores. So that's like the meat of their students. SAT scores are the middle 50% are in here. So that's kind of related to what we're about to do. So what we're going to do, the book calls it something less interesting, but the actual title of this graph, bless you, is a box and whisker plot. I am not joking. So the book calls it a box plot, but it really is a box and whisker plot. So in case I say this, you'll know what I'm talking about.
It's like a whisker, like
No, whisker like on a cat. Yeah. Or anything that has whiskers. Yeah. It's the freakiest word, whisker. Right. So here's how this works. It's almost too easy to believe, but it is really powerful, quick visual of something. So let's say this is a group of students who took the ACT score, the ACT test, for example. Right? ACT test is like the SAT test, just not. Bless you. What kind of scale can I use to maybe make sure that everybody has a place to go?
5.
By fives makes sense, because the first one's 5 makes sense. So 5, 10, 15, 20, 25, 30. All right, Mayor Quimby. I'm here today. All right. So hopefully you don't write as poorly as I do. Now, here's the neat thing. Just put a line like this on top of each of the pieces of the 5-number summary. So there's 5. That's the low. Q1 is 14. It's a little bit below 15, so we'll put it right there. That's crazy, right? 21 and a half, all right, so a little bit above 20. Bam. 27, all right, 27 is a little bit below halfway there. Bam. And then 31, a little bit on this side. Bam. Easy so far, right? You've never done that before, but hell, that's easy. Now box off this. There's the box. And then these are the whiskers. So I don't know if any of you guys have ever seen this type of image before, but very often they show up related to education. In fact, if there's any education majors in here, this is a huge thing we're supposed to talk about. So let me ask you this. So let me ask you several things. Can anybody tell me, this is going to sound, if you're not sure what's going on, it's going to sound like, how the hell would I tell you that? What percentage is in here? Why? What's this line represent?
25.
No, careful. That's the 75th percentile. This is the 25th. So of course there's 50. If there's 75 below that and there's 25 below that, there must be 50% there. So when they talk about the middle 50% GPAs, the middle 50% SATs, they've created a box plot and they just look at it. Right? This is also called the interquartile range. Yes, ma'ams and sirs. Interquartile range, which I'll never fully write out. It's just the IQR. IQ what? IQR.
Sounds like something from Star Trek.
It does.
Right?
It does. IQR says 7. Oh shit. What does that mean? I don't know. So the IQR is Q3 minus Q1. So for example, for this data, the interquartile range is 27 minus 14, which is 13. It's crazy. So when they ask you for the IQR, that's all it means, Q3 minus Q1. Gives you the range for the middle chunk of students, or whatever you're talking about in that case.
Wait, so 13 represents?
The range of the middle 50%. So if I wanted to go, so if one school said our IQR for GPAs, incoming GPAs, is 2.3 to 3.1. So that's IQR at this first school. And another school said their IQR was 2.4 to, well, I don't care, 3.9. Which school seems to be more selective? The second one, right? I mean, and that would be kind of like a point of boasting for them, right? Even though GPAs really don't mean shit related to what you know or what you're capable to know. It's too bad for us, we live in that kind of society. Ooh, that was a statement. All right. Because my GPA, to be completely honest, in high school was horrible. I got a straight 4.0 in 8th grade. I'll start off there. 9th grade, I had a 1.4. Why do you think that happened? Because Jeff started hanging out with the wrong people. And my parents didn't really do shit to me. But oh. Jeff got himself together and pulled that GPA back up somehow. All right. A little cautionary tale, kids. So visually, if I said this is one school, or this is one group of students, and then I do like a workshop before the test to help another group of students out, and theirs comes out to be this, is this good evidence that my workshop helped?
Yes.
Yes, because the middle 50% is much higher than that. I mean, the lowest is higher than that. And so this is evidence that my workshop had an effect on students' grades, which is a huge thing that stats is always trying to do. Evidence that this drug works better than the old drug, right? Evidence that eating eggs causes this horrible thing to happen. And then next week we'll say, no, it's actually good. And then next week we'll say something else. Right? You guys kind of with me? Or if you don't pay attention, it's probably a good idea, because it'll just contradict itself eventually. Eat lots of chocolate. Don't eat any chocolate. Drink lots of wine. Don't drink any wine. Oh, shit. Forget it. Just do what you want. All right, so that's box plot, otherwise known as box and whisker plot. Cool. So you guys feel decent about that? That's so desperately not difficult, really. Please let that not be difficult. It's new, but it's not difficult. Nothing's difficult yet. Oh, let's see. I feel like I missed something. No, I guess not. Okay, good. All right, so let me do this. Let me give you guys some data, and then I want you guys to create the box plot, just to make sure that you all... Actually, we'll do this. Do it for the data I already gave you. Go back to this paper and make the box plot for this data. Right, some of you guys have the mamas, some of you guys have the papas?
Yep.
All right. Hopefully you still have the sorted data. If not, oh well, too bad for you. Got to sort it again.